Well, in this video, we're going to talk about the inverse properties of logs. And we've actually already seen some of these at work. So, as usual, b is going to be the base of the log, and it's a positive number, and it's not equal to 1. So log base b of b to the x, this is a generalization of what we did in the previous video, is just equal to x. And you can check your work by saying b, this base b, raised to this power gives us b to the x. b to the x equals b to the x. So you can do some of these with very little thought necessary. This is equal to 6. The exponent you raise 7 to get 7 to the 6th power is a 6. 7 to the 6 gives me 7 to the 6th power. Ln, remember that's log base e, so it matches this, the base of the exponent portion. Log base e of e to the negative 2 is negative 2. Again, there's a base e down here, so you can test it by e to the negative 2 gives me e to the negative 2. Now let's do it the other direction. Let's take an exponent term where the exponent has the log in it. Well, remember what this exponent is. This is the exponent you raise b to get an x. And we're raising b to that exponent, so we get an x. Okay, it's very simple. You need to make sure that the base b of this exponent term, here's the exponent, this is the base. The exponent is a log of it in itself, log base b. As long as that base matches that base, your result is whatever you're taking the log of right here. And a couple examples. 3 raised to the log base 3 of 17. It's simply 17. All right, and this one is, let's see, I really should put parentheses around that because it's ln of negative 3. ln minus 3 doesn't make sense because you have to take ln of a number. So you need the parentheses just to make it clear. And remember, the base of the log, ln, is e. So this e matches the base of this log. E to the ln negative 3 is simply negative 3. All right, so to finish up here, don't forget that log of x means log base 10 of x. And make sure you write this base as a subscript. Don't let it look like log of 10 times x. It's log base 10 of x. And ln, natural log of x, means log base e of x. And before finishing the video, I just drew a little simple graph here. I wanted to show you how, let me write down something first. Inverse functions. F of x equals log x. And g of x equals 10 to the x. Those are inverse functions. Log base 10 of x and 10 raised to the x power. Exponential function, log function. And I'll do one more. I'll do f of x equals ln x. And g of x equals what? The base of this log is e, so this should be e to the x. Okay, so you could do that with any base that you want. You could say log base 9 of x, f of x equals log base 9 of x, and g of x equaling 9 to the x power. Those would be inverse functions. And let's just deal with these two here. Well, e is a number that's about 2.7. We've seen what 2 to the x looks like, and we know it goes through the point 0, 1. And it goes something like this. Roughly speaking, that's f of x equals e to the x. And notice, it's always positive. There's no exponent you can raise e to get a negative number because e is a positive number. Well, the reason I drew the line y equals x, that 45-degree angle straight line, is because remember that all inverse function pairs are symmetric to each other about this line. So instead of 0, 1, it's going to have a 1, 0, and it's going to look like this. And this I'll say is g of x equals ln of x. So that just kind of shows how they are inverse functions. They're mirror images of y equal x. And the log function, notice it's not defined for negative numbers over here. You can only take the log of positive numbers. And as I mentioned before, the e to the x always gives you positive numbers. So the domain of the domain of this function is the range of this function, and the domain of this function is the range of this function. You can see by examining this. The domain of f of x is all values of x. You can plug in any value you want for x. Well, the range of this function is any value of x. It goes all the way down to negative infinity, and it'll climb all the way up to positive infinity. So log base 10 of x, let me put it over here, log base 10 of x and 10 to the x are inverse functions, and ln of x and e to the x are inverse functions.